Hi guys, welcome back. Today we are going to figure out how to avoid abnormal exit statuses on fitchfork. For more information on how fitchfork works, check out our Demystifying Fitchfork Explainer. The link is in the description below. First off, we start by carefully reading through the entire spec file and gain an understanding. Any unsurety, error, or omission may be brought to faculty staff attention. When doing this, we take note of the classes and their order, the libraries allowed, the UML diagrams, the compiler standard allowed, and files required to be compressed and uploaded. Abnormal exit statuses on fitchfork are caused by your files failing to compile on the server. Here is a list of such causes. This is a cookie cutter method to avoiding abnormal exits on fitchfork. First, we will start by creating a basic main template to test if our setup compiles. We will then create a makefile for our project. We create the default rule called by make. This uses G++ to compile CPP and object files and outputs an executable file. The -G flag is for debugging, and a link to that tutorial will be posted in the description below. Next, we create a rule to run the program. A side note, the // is the Linux equivalent of .exe in Windows. We then create a rule to clean junk object files before our next compile. A link to useful Linux commands and their uses like ls, rm, make directory, and touch will be made available in the description. *.o is short for all files ending in .o, and we will also remove the executable created. Lastly, we will create an instruction for easily compressing our files for transfer or upload. Please note that the section highlighted in red is dependent on which files you intend to include in the compressed file. You may run your makefile to ensure that no errors were made. We now move on to creating our object class header and code files. When coding, we always follow a rule of coding from class of least dependence, meaning the class with the least aggregation or inherits the least from other classes. In this example, we note that creature aggregates no other class, whilst team aggregates creature and main aggregates both in testing. Hence, we will start with creature. Taking note of the exact spelling of creature, we create the header file using the prescribed format. Slight changes to the format regarding the use of namespace standard may occur. Please read the spec file to avoid getting caught with these. Next, we will add all the prescribed headers to this class header file. Take note that we will only add headers and using namespace in the header file and not the code file. For every other class that includes, meaning aggregates this one, we will not repeat the prescribed headers. When transcribing the UML, we first print the type, which is the part after the colon, and then the member name. Do not add, remove, or change the formatting of these member variables or function names whatsoever. Take note the method and notice there are absolutely no changes to formatting of the UML. We then copy the member functions and continue to make the code file. This is a form of error checking. If you have made an error in formatting or declaration, you should know to update both header and code files since it was copied over and not have to determine in which file the error is present. If done right once, always done right. If done wrong twice, it's easier to discover and correct. For the CPP file, all we do is include its own header. The other headers and namespace standard are all included when adding the header since they were included in it. We then add the class scope specifier to each of the member functions. Make a note that it is positioned after the type and immediately before the function name. In preparation for testing, we add our last class that is aggregated the least but aggregates the most to the main. For this demo, we have only one class, so we will add creature. To add a class to the makefile, we first write a general instruction to run with default, to compile and generate the class as an object file. We then add the object file to the default rule to be compiled into the executable like so. We follow these two steps for every new class we would like to add. We can call make to ensure we haven't made any compiler errors yet. On a side note, we have created an extension available in the VS Code Marketplace. Simply search Studymate and you will see a snippet extension. Click install and use the snippet code SM at the top of any C++ file to see our extensive range of ready-to-use C++ snippets. Snippets for Makefile as well as other languages will be released shortly.